Hi, I'm Li Hanjing from Group 2. Next, we are going to do the KIB 1011 video assignment. The topic is straighter. These are members of Group 2 and they are Farah Nusha, Deputy Muhammad Shahami, Li Hanjing, Maya Hanan bin Aziz, Joel Shur, Farisa Insurance, Li Zuhani. A straighter is a biomedical device that used to carry patients with biomedical care from one place to another. It's composed of a lens made fresh shower later in steel wire. It's easy to fold and has low bearing capacity, which is characterized by the mobility and convenience, but also high strength to withstand a large load and easy to clean. Disinfection, the size and also relatively long, very reliable. The straighter is remarkably designed and equipped with specific features to ensure patient outcome acceptance. The important function of the straighter is that it allows the patient of further injury and optimize or safe carrying an injured person manually. It provides a step and step service for transporting patients to reduce the risk of further injury and optimize the care provided. First, I want to introduce the single straighter spinal board. It's a patient-handling device primarily in pre-hospital trauma care. It is designed to provide immediate support during the movement of a person with suspected spinal injuries that was used by ambulance staff as well as lifeguards on ski vertebrates. Next up is a very common emergency straighter. It's also known as a falling straighter, centralized and emergency straighters are useful for assisting patients who require transport outside of the hospital. And then the electric step straighter is ideal for helping emergency medical professional transport patients up and down staircases. Ambulance straighters are fully made of carbon alloy. Straighters made of carbon alloy are excellent for emergency medical services because they're strong by making it easier to put into ambulances and to carry patients easily in empty static. Now it's time to introduce the protagonist of the report. Medical straighters are typically composed of plastic, iron, foam grids, and mostly alloys, particularly aluminum alloy. Firstly, the hydraulic jack portion of the straighter is composed of steel on the inside and nitrile rubber or synthetic materials as seen outside. The following will be a detailed introduction to the material and design of the medical straighter.
Now we will move on to the materials and design of a medical structure. First, we look at the materials that is made up of foam cushion. Foam cushion provides softness and comfort and has excellent support by distributing weight evenly. Next is the cover that is made up of plastic to make it lightweight despite its big size. Moreover, stretchers also have hydraulic jacks that are made up of steel on the inside and natural rubber on the outside. Steel is being used to provide the necessary strength and hydrophility. Meanwhile, natural rubber can help prevent fluid leakage and maintain a tight seal between moving parts. Lastly, aluminum alloy that made up most of the structure. It is being used because alloy-based materials are lighter than pure materials, have a hydrophility and great strength. For the methodology, we basically went to the Department of Engineering PPM and asked permission and scheduled to see its lecture. Then we visited emergency trauma in PPM and listened to briefing and explanation by PPM staff. Next, we identified various structures, took a picture, measured them and jotted down all the data. The staff also lent us the structures manual book for the measurement. Lastly, we write the report based on our research and calculation.
Our main objective of reviewing the study is to perform equilibrium based analysis of various structure in stretches using three diagrams. Secondly, we wish to solve problems involving a body under the action of action, bending and torsional load in a stretcher. Thirdly, we would like to employ moment of inertia based on analysis for problem solving due to compound load in stretcher. In addition, we wish to evaluate stress and deformation in a stretcher. Last but not least, we wish to perform effectively as a in analyzing real-life cases of stretchers which are static objects under loading. Before we draw the everyday diagram, few assumptions are made, which are the stretcher is in equilibrium, the weight of the person is well distributed along the stretcher, and there are reaction forces acting due to the weight of the person. So we draw the everyday diagram, which is change the diagram into a 2D diagram, and then indicates all the forces acting on the stretcher, which are the force from the person and also reaction forces from the wheel. So when the stretcher is in equilibrium, the total forces and total moment is equal to 0.
Next, our group will be presenting calculation and results. It will cover axial bending and torsional load, moment and inertia, and lastly stress and deformation. So first, I will be explaining the bending concept at the side rails. So we wish to determine the maximum tensile stress and compressive stress that acts on the side rails of stretcher when a force from pusher's hand, let's assume F equal to 5 Newton, is applied to bend down the side rails of stretcher. While doing calculations of bending, we need to do some assumptions, which is the first one, the structure is in equilibrium state. Second, force exerted by hand to close the rails is 5 Newton. Third, force exerted must be on the second rails that are parallel with the red button on the below. Fourth, the side rails are made of aluminum alloy. So first, we need to find the bending, the maximum tensile stress by using the formula negative my divided by moment of inertia. So after finding our moment, which is 1.9 nanometer, and we find our y, which is 0.01, and also our moment of inertia, just put the calculations, the value into the calculations, and we will get the maximum tensile stress and maximum compressive stress. So also we wish to determine the moment that the best frame can withstand. Since the side rails are made of aluminum alloy, we just put the value into the formula, we will get the maximum moments that side rails of stretcher can withstand before its break is 43.9 megananometer.
Next, we also have a bending concept at the base frame. This is our free body diagram, and we want to determine the tensile stress and compressive stress that acts on the base frame when these assumptions are made. Firstly, we apply the moment of inertia concept on bending, where Ix is equals to 1 over 12 bh cubed, as the shape of this structure before bending is a rectangle. Then we calculate all the dimensions and find the moment. We assume that the structure is in equilibrium state and y is equal to 0.1 cm. Now we solve it by using the equation sigma equals to negative my over I. Then we determine moment that the base frame can withstand by applying the value of maximum tensile strength and maximum compressive strength of aluminum alloy, which is applied to previous formula and compare the two answers. Choose the smaller value as maximum moment. Next, stress and deformation concept at hydraulic jacks. We wish to determine the total deflection of the hydraulic jacks when the length is in minimum value, and these assumptions are made. First, for PD, we separate the structure into two parts and find pressure 1 and 2. Then we calculate all the dimensions needed and put it into the formula of total deflection, which is PL over AE. After that, we want to discuss how the length of the jacks and weight affect the total deflection by substituting the maximum length and maximum weight of the section into the same formula. From that, we can conclude that total deflection is directly proportional to the length of the hydraulic jacks and the force acting on it.
Moreover, we do apply axial loading in the context of IB pole in the calculation. Determine the deformations of the IB pole which made from stainless steel shown under the assumed law. Do have a look at the assumptions stated. In order for us to calculate the deformation, we should know all the values of internal forces applied. So first of all, apply a free body analysis on each component to determine the internal force. Then, evaluate the totals of the component deflection using the formulas of deformation delta equal to PL over AE. Other than that, we do also apply the principles of torsional law at the IB pole. The problems that will be discussed are find the largest torques and angles of twist. For A, we have to find polar moments of inertia Z, then given allowable shearing stress and maximum radius, invert the elastic torsion formulas to find the largest torques. Whereas for B, we can directly use the formulas of angles of twist to solve.
Next, I would like to continue to explain the concept of stress and deformation of the structure of a structure. Firstly, we found that the crank of the knee rest experiences deformation when adjusting the knee rest. So we wish to determine the deformation of the crank when these assumptions are made. Firstly, when the knee rest is on equilibrium. Secondly, when force applied is 2 Newton. And then the crank is made up of aluminum alloy. The Young modulus equals to 220 gigapascal. First, we have to draw the free diagram, and then we have to draw the forces and also the measurement needed. And then we have to use the formula D equals to P A over E. So just to take the value into the equation, and then we get the answer. So force is applied on the crank to adjust the knee rest in relation to the basic condition and comfort. So when there is no force applied on the crank, the knee rest is locked and unable to move.
Next, let us delve into details of what summary we have gained from our calculation and result in our finding. First, through the creations of a detailed free body diagram, we've meticulously identified and isolated the forces acting on the specific sections of the hospital structure. This diagram serves as a foundational tool for the subsequent calculations. By systematically breaking down and analyzing the force involved, we gain a comprehensive understanding of the external loads and internal reactions within the structure's component. In addition, it's also provided a solid basis for ensuring the structural integrity and optimal performance of the structure. The free body diagram, as a key step in the analysis, play a crucial role in guiding the subsequent calculations and enhancing the overall design process. We apply principles of stress and deformation to gain valuable insight. Stress calculation allowed us to assess the internal forces within the material, while deformation analysis provided information on how the structure's part respond to these forces. For the case of knee rest, forces and load analyzers consider patient weight and additional equipment, ensuring equilibrium and stability through static principle. Simultaneously, deformation analyzers utilize delta equal to AE over FL, estimating potential deformations under applied forces, with E representing the Young modulus. Deformation analysis help in predicting and controlling the amounts of displacements or deformations the crank may experience under different loads contribute to stability. Turning to the hydraulic jet, pressures and force analysis calculated force exerted by the system, while stress and deformation evaluation ensure the integrity of hydraulic component. Stress analysis on hydraulic components help ensure that material can withstand the pressure and forces generated within the hydraulic system. Proper stress distribution prevent material failure and ensure the longevity of hydraulic components.
Third, moment and inertia. So moment and inertia is distributed forces whose magnitudes are proportional to the elemental areas on which they act and vary linearly with the distance off from a given axis. So the given below is the formula for moment and inertia. So in moment and inertia, we also have parallel axis theorem to calculate the moment of inertia of a rigid body when the axis of rotation is parallel, but not necessarily passing through its center of mass. So since we have calculated the moment and inertia at the side rails, the base platform, and also the handle, so it's very important to analyze moment and inertia in certain structures of objects because we can predict how structure respond to applied loads, especially when subjected to the rotational forces. So the distribution of mass and the resulting moment of inertia affect the stability of rotating objects. So objects with different mass distribution may have different response to external torque, impacting their stability during rotation. Lastly is the discussion about the axial, bending, and torsional load. So the first one is axial loading on the IB poles. So the calculation for axial loading is very important because it's crucial for buckling analysis, material selection, load transfer, and to find the failure analysis. Second is the bending in the in the side rails and also the base platform. So it is very important to identify the tensile stress and compressive stress at certain point of structure that bend. So it will be prevent exerting forces that might result in the failure of the object by calculating the maximum stresses that can be applied. And lastly is a torsional loads. So torsional loads are critical in the design of shaft. So it's ensure that shaft can withstand the twisting forces without experiencing torsional deformation or fracture. Also, it also helps engineers to design components that efficiently transmit torque without experiencing excessive torsional stress. Right now, I will be presenting limitation parts. So the following discussion is to focus on limitation based on the structure and how this limitation can affect the structure performance. So the first limitation that we can find in the structure is height of handles. So the height of handles is only 20 centimeter. So the height of handle is too short and could not be adjusted to higher positions. So it will be difficulty for a person to push the structure as their body need to bend down to hold the structure handle. Second, the limitation on the structure that we can find is the size of guide wheels. So the length of the guide wheels is 19 centimeter and the breadth of guide wheels is 2.5 centimeter. While on the other hand, the average length of adult foot is 27 centimeter, while the average breadth of adult foot is 8.93 centimeter. So the length and the breadth of adult foot is too large compared to the guide wheels. So it will create instability of the foot towards the guide wheels. So the chance of that person might be falling over is high.
In light of the identified limitations, this is an opportunity for enhancement and refinement in our approach about a stretcher. A stretcher is a vital piece of medical equipment designed to facilitate the safe and efficient transportations of patients within healthcare facility. So, in our pursuit of advancing patient care and medical equipment efficiency, our focus has turned to enhancing the functionality and design of the hospital schedules. First, height of handle. We can design it into a handing pushers with adjustable handle to accommodate nurses of different height. This can also allow quick and easy changes to the handle height. In addition, if based on the formula W equal to FD, we can conclude that the work done will be more efficient when the force is applied at an optimum height. Second, size of guide wheel. Scratchers are equipped with a brake pedal or braking system to ensure stability and safety during patient transport. Improvements to the size of brake pedal or guide wheel should consider factors such as ergonomics, ease of use, and safety. Here are some suggestions. First of all, we should increase the size of the brake pedal to provide a larger surface area for healthcare professionals to operate. Not only that, by increasing the size of brake pedal, we can effectively increase the lever arm length. According to principles of leverage, a longer lever arm requires less force to produce the same torque. Therefore, a larger brake pedal makes it easier for healthcare professionals to engage and disengage the brake. Other than that, extending the lever arm connected to the brake pedal can increase the lever arm length, providing additional mechanical advantage. The torques applied by the foot or hands is amplified, requiring less force to engage or disengage the brake.
Conclusion, we learned much valuable knowledge throughout this assignment. Since we are choosing medical stretcher as our focus of biomedical devices, we have received a chance to visit real-life stretcher at the Department of Engineering PPUM. Besides that, this assignment allowed us to use the serious knowledge that we have learned during classes and apply it in a real-life situation, especially from the standpoint of statistics. Finally, research gives us a deeper understanding of the functionality of medical stretchers and make us realize that stretchers are not only an assisting tool, but also a technical that closely relates to lives of users. Through continuous research and improvement in the future, we believe that the efficiency, comfort, and adaptability of stretchers will become better and better. Thank you for your listening.